All right, welcome everybody to another live stream, a double live stream in this case, for this week. And what I wanted to do, just having a quick little thing here so I can open the chat. So the reason why I'm going live is because I gave another quiz to my students last week, and I kind of got behind because, like I as a student, I was like, I just don't really feel like grading at this point in time. So therefore, it's kind of taking me a little bit while. So I did the quiz. Quiz number 1, I did that live stream on Sunday for analytic trigonometry, as well as then this week I gave their quiz 2 on Friday and Monday. So what I wanted to do is just kind of cover that because obviously I'm still going to be uploading videos. We're getting into our next chapter, which is going to be the applications of trigonometry. So if you are following along with my kind of course, we will be getting into doing some word problems with trig. We're going to do law of sines, law of cosines. We're going to get into vectors, parametric equations, and polar equations. So that's all coming up on my channel as well as for my quizzes. I do some of you guys joining in. I'm not going to do an open kind of Q&A, which that's what I do on every Sunday night. But I do appreciate you guys joining in the chat. And if you do have some questions, I'll maybe kind of see after I've gone through the quiz. Maybe I can answer any like direct questions or kind of indirect questions. From there. So I see you, Clayton TTV, OM, Aman Dodd, Dora Kuhn. Thank you very much, guys, for joining in. And I appreciate you guys joining the stream. So let's go ahead and get started. And again, what I'll do is I just want to kind of finish this, get through this quiz that I recently gave. And then what I'll do is just kind of open some questions for you guys after that. So, all right, let's go ahead and get started here. So the first question was evaluating for tangent using the sum and difference formulas. So what we needed to do is just remember to use the formula, and my students had the formula sheet. So therefore, using the formula for tangent of the difference of two angles, we'd have the tangent of 3 pi over 4 minus the tangent of pi over 6. And then all over 1 plus the tangent of 3 pi over 4 times the tangent of pi over 6. So again, this is just using direct substitution, pretending, these are my angles U and V. And basically, I'm just plugging them into the formula. Now, the next set where we needed to, make some corrections, which I did grade some of the students' quizzes, and some mistakes is, just evaluate it. I mean, this is just going to the unit circle, saying what is the tangent of 3 pi over 4? Well, again, remember 3 pi over 4 is here. That is the y coordinate over the x coordinate. So that's going to negative square root of 2 over 2, comma square root of 2 over 2. So again, when you take the y coordinate over the x coordinate here, that's going to be a -1. And then for pi over 6, that's going to be this coordinate point right there. And remember, that's square root of 3 over 2, comma 1/2. So in this case, when you go ahead and take the y coordinate over the x coordinate, you're going to have a positive square root of 3 over 3. But again, you're subtracting that value, right? Did I get this? Yeah. So it's going to be a square root of 3 over 3. And then we'll have a 1 plus a -1 times a square root of 3 over 3. Okay, so that's basically now evaluated. Now the next portion that we do here is just really kind of simplifying this. And what we're going to want to do here is the first kind of round I like to do is just multiply everything by 3. Actually, let's kind of make it right like this. So we have -1 minus the square root of 3 over 3. And technically then now 1 minus the square root of 3 over 3. So they look very same, but we can't divide them out across subtraction. So what we're going to need to do in this case is multiply by a 3 over 3. And again, as long as we multiply by the same number on top and bottom, that's going to produce an equivalent fraction. And then just make sure you apply distributive property here. So therefore I get a -3 minus the square root of 3 all over a positive 3 minus the square root of 3. Now, we can go back here, and now our next step is, I'm just showing all my work, so I'm kind of taking a little bit longer to do here. So now, to get rid of our radical in the denominator, we're going to multiply by the conjugate. So therefore, I do 3 plus the square root of 3. I really don't like doing work from the right and to the left, but that's just the way that I have here. So in this case, I'm going to have a -9, and let's see, minus the square root of 3. And then another minus the square root of 3. Sorry, minus a 3 square root of 3. right? And then negative square root of 3 times positive square root of 3 is going to be a negative 3. And that's all over. This is a difference of two squares, right? So you can see that's going to be a 9 minus 3. All right, so now let's go and combine like terms here. Negative 3 minus, negative 9, minus 3 is a negative 12. And this becomes a negative 6 square root of 3. And this is all over a 6. And then you can divide that 6 into both those terms to give you a negative 2 minus the square root of 3. And that was going to be our final answer right there. Okay, so I don't really, you can see here, just working again, this is basically getting to the evaluating, and then all of this is just that simplifying version. For the next example, the evaluate the sine of theta equals negative 3/5, where cosine of theta, forgot to fix that, is greater than 0. So in this problem, we needed to create a triangle. And the triangle, we need to determine not only just any triangle, we need to determine a triangle that is in the correct quadrant. So sine is negative. So what that tells me is that the triangle has to be either in the third or the fourth quadrant, right? Because if sine is negative, that means the y-coordinate is negative. So remember it's opposite over hypotenuse. So we know that the hypotenuse is going to be 5. The y-coordinate is going to be a negative 3. Then it says the cosine of theta is greater than 0. So that means obviously that has to be to the right of the y-axis. So therefore you can see my triangle is going to be in the fourth quadrant. So that's going to be a 5. And then, that's 5. And then by using the Pythagorean theorem, or you can recognize this to be a Pythagorean triple, that's going to be 4. Now, for the half angle, what we recognize here is, again, here is going to be our angle, but really our angle theta is right here. So you can see this angle is in the fourth quadrant. Therefore, when we are going to use the half angle formula, we're going to use the negative version of that radical, because the half angle, which is theta right here, right? Right now, we're basically just using the reference angle of theta. So if we take theta and divide it by 2, we're going to have an angle that's in the second quadrant. And when theta divided by 2 is in the second or in the third quadrant, the formula is going to be the negative square root. So in this case, this angle is going to be in the second quadrant. So when I go ahead and plug this in, if you look at the formula, it's plus or minus. In this case, our half angle is in the second quadrant, or will be in the second quadrant. So we're going to use the negative version. And that's going to be 1 plus cosine of theta, which is cosine is going to be adjacent over hypotenuse. So that's going to be 4/5 divided by 2. All right. And now what we need to do is just go ahead and simplify this. So to go ahead and simplify this, did I do that, things? Yeah. So to go ahead and simplify, let's actually just go ahead and write this over here. Let's just rewrite it one more time. So 1 plus 4 over 5 divided by 2. I'm going to multiply by a 5 over a 5. And again, under the radical, you can go ahead and do that. Again, we're not changing anything. Okay, so when I do that, I now go ahead and obtain a 5 plus 4 all over 10, which I can now break into the square root of 9/10, which can be rewritten as 3, right? The square root of 9. Now let's just do it like this, which can be rewritten as the square root of 9 over the square root of 10, which is 3 over square root of 10, which you can rationalize the denominator to 3 square root of 10 over 10. And again, remember that answer is negative. So we want to make sure that we're keeping that negative all the way through. Don't forget about the negative. The next example is just using the double angle formula for sine, which is going to be 2 sine of theta cosine of theta. So in this case, all we're going to do is take 2 and then multiply by the sine of theta, which is negative 3/5, and then multiply that by the cosine of theta, which is 4/5. Okay, and when you multiply straight across here, you're going to get a negative 6 times 4, which is a negative 24 over 25. All right. So that was the double angle, half angle, and sum and difference. And then the next one was go ahead and the identities. So in this case, we want to confirm that the left side is equal to the right side. You can see that we have the double angle formula here. And you know, kind of the one thing I look at here is we know we're going to want to work on the left-hand side. And the tough thing with having the double angle for cosine is we don't know which formula for cosine we're going to use. Now, I pretty much told students to use whatever formula you wanted to use. You know, just try one, and then if it doesn't work, then try the other one. But I also gave them advice that I would recommend using for evaluating to at least use cosine squared minus sine squared first. And let's go ahead and do that. So when I do cosine squared minus sine squared, that's of x, all over cosine of x minus sine of x. Now, I did recognize what some students did here is they recognize on the right-hand side it's sine of x plus cosine of x. So what they did is they multiplied by the conjugate in the denominator, right? Because the important thing for you to recognize is the left-hand side is a fraction. The right-hand side is not a fraction. So somehow we have to figure out how are we going to get them to not be a fraction. So one thing, you could multiply by the conjugate. It got a little messy, or some students, I wouldn't expect them to be able to multiply the cosine of x minus sine of x and to kind of like see how those terms worked out. But based on the work that they did, everything kind of worked out. However, what I would recognize is this is, again, the same thing as, when you see a square term minus another square term, that's the difference of two squares. So all we simply need to do here is just factor this out to cosine of x minus sine of x times cosine of x plus sine of x. And that's going to be all over cosine of x minus sine of x. And therefore, you can see those quantities divide out, leaving us with a cosine of x plus a sine of x. And therefore, you can see that's exactly what we have on the other side. It's obviously, I just flipped it around, but that's okay because it's addition. So you can work in any kind of order. All right, and the last free response I gave my students was a solving an equation on the interval 0 to 2 pi and using the sum and difference formulas. So the first thing they need to do, or first thing I was looking for when they were doing this, was to at least apply the formulas, right? Even if they didn't get anything right from there, I wanted them to at least apply the formulas and then, evaluate those formulas for the sum of those two angles. So using the sum of two angles for sine, as well as the sum of two angles for cosine. Let me see, hold on a second. What we can do is just go ahead and plug in the video. So let's go and take a look here. So we have sine of x cosine of pi over 4 plus the cosine of x times the sine of pi over 4. Now, let's be careful when you're subtracting. We're going to want to use parentheses here because we're not just subtracting the cosine of x plus 4, but that's going to break up into an expression. So we got to make sure we subtract both of those quantities. So now I'm going to use the sum of two angles for cosine, which is going to be the cosine of x times the cosine of pi over 4 minus the sine of x times the sine of pi over 4. Okay, and that's going to equal 1. Now, you could go ahead and distribute this, right? Because this negative gets distributed to both terms. I'm not going to rewrite, well, actually, I might as well. Let's just do this. So then students can see what happened here. So I'm not going to evaluate though yet. I'm just going to rewrite it. I didn't expect anybody to do this, but I just want them to see. Again, you can skip this step. I'm just doing it because I'm a teacher and I want to show you where that work is coming from. All right, so now I distributed that negative. That means that's a positive now. And then what we want to do is look for, all right, is there any terms that are exactly the same where one is negative, one is positive? And you can see that, yeah, these two, nope, not that term. Let's see, that's a negative, cosine. What happened here? That's a plus, that's a minus. Where are my terms divide out? Oh, okay, yeah, so nothing's divided out. So good point. So nothing went ahead and divided out. So actually, then what I'm going to need to do now is let's go ahead and evaluate them. So cosine of pi over 4 is square root of 2 over 2, and sine of pi over 4 is square root of 2 over 2. So actually, I skipped that step when I did my key, and I just went to this step, which is better because you can see what divides out a little bit easier here. Sine of x times the square root of 2 over 2 equals 1. All right, now you can see that these cosines, here the positive as well as the negative, cosine of x times square root of 2 over 2 divides out. And now you can see we have 2 sine of x's times the square root of 2 over 2 equals 1. Well, now the 2's divide out. So I'm just going to be left with a sine of x equals the square root of 2. squared times the square root of 2. Sorry about that. I'm kind of skipping a little bit quickly. Equals 1. So therefore, the sine of x is equal to 1 over the square root of 2, which can rationalize to the square root of 2 over 2. And again, my question said find all the solutions on the interval 0 to 2 pi. So looking at the unit circle, which is that interval, when is sine of x equal to a positive square root of 2 over 2? Well, since it's positive, we know it has to be in the first as well as the second coordinate. So then these two angles, I'm just going to use my solution set here, is going to be pi over 4 and 3 pi over 4. And there you go. Yeah, there we go. That's it. All right, so then the last part of the quiz is they had some multiple choice to go ahead and complete. So for the first problem is basically evaluating. And what we want to do in this case is understand what exactly the function is a representation of. Which formula is this? And hopefully you recognize that this is the sum of two angles for cosine. So this is the formula. If I was going to evaluate this, this would be the cosine of 310 degrees, plus 50 degrees. So that's equal to the cosine of 360 degrees. Now we need to go ahead and determine is where exactly is what is the value of cosine of 360 degrees? Well, again, remember 360 degrees is, one revolution of the circle. That coordinate point is 1, 0. So again, the cosine of that value is going to be 1. The next one is finding the sum formula. And when it says the sine of theta equals 1/3, it says that our angle lies in the second quadrant. And we already have one other angle, which is pi over 6. So let's see here. Applying the sum formula, I do need to figure out what the cosine is. So let's go. Let's just write out the sum formula here right now. So I have the sine of theta times the cosine of pi over 6 plus the cosine of theta times the sine of pi over 6. Okay, so we know the sine of theta is 1/3, right? So that's going to be 1/3. We know the cosine of pi over 6 per the unit circle. That's going to be square root of 3 over 2. We do not know what the cosine of theta is, and so therefore we can figure that one out. And then we need to figure out the sine of pi over 6, which is 1/2. So let's go and figure out what the cosine of theta is. So if we know sine of theta is 1/3, and we know the angle lies in the second quadrant, the graph's going to look something like this, right? 1, 3. And therefore we just need to figure out what this value is. So just go ahead and using, Pythagorean theorem here, 3 squared, let's call this x, equals x squared plus 1 squared, right? Well, therefore that's going to be 9 equals x squared plus 1. So therefore x equals plus or minus the square root of 8. Now you could simplify that, but you can see there's a square root of 8 here, so I'm not going to simplify it. But since we're in the second quadrant, we know that needs to be a negative square root of 8, right? So you can see how that plus or minus plays a role here. So therefore the cosine is going to be negative 8 over 3. So we have plus a negative square root of 8 over 3. And then remember that the sine of pi over 6 is 1/2. So when you multiply those out, you can see that the common denominator is 6, and we're going to have a minus 8. So we'll have a square root of 3 minus the square root of 8. So you can see the answer is going to be C. I think I had that right. Oh, no. I messed that one up. That's a sine. Yeah, plus. Huh. I did that one wrong. I have to check my answers now. The next one is evaluating the half angle formula. Now, again, in this case, we can see that if I'm going to use the half angle formula, then I have cosine of theta divided by 2. That is my half angle. Since my half angle is in the first quadrant, right? 22.5 degrees was in the first quadrant. It's not this answer, and it's not that answer. So you can see the difference. Well, you can see in that other example, since the half angle was in the second quadrant, that's why we had the negative version. But now we just basically need to plug this in. So again, if u, or theta, whatever, let's use theta, I guess. If theta over 2 is equal to 22.5 degrees, then what does theta equal? And theta equals 45 degrees, right? You just multiply by 2. So now I'm going to use the half angle formula, which is going to be the positive version, so I'm not going to worry about that, which is 1 plus the square root of 2 over 2 over 2. And then hopefully, without even simplifying, I'm never going to make this negative. So you can see the answer is D. I don't really need to simplify my work. I can see just from using that formula what the answer is going to be. The next one is if x is an acute angle and cosine is 4 over 5, then cosine of 2x is. So again, we need to figure out the sign. So this does not give us any other restrictions. So therefore, we're just going to assume that this is a triangle in space, right? Where this is 4 and that's 5. So therefore, that's x. Therefore, we'd use the Pythagorean identity or triple. You can say that's going to be 3. So the formula that I always like to use is cosine squared minus sine squared. So I'm just going to take the cosine, 4 over 5 squared, minus the sine squared, 4 over 5 squared. Okay, so I have 16/25. Sorry. Minus 9/25, which is going to give me a 7/25, which is D. All right, last but not least, guys, is the expression 1 minus 2 sine squared of 30 degrees has the same value as. And now we just need to recognize which formula this is. And this actually is the double angle formula. And the double angle, oh no, sorry. This is the cosine formula. Double angle for cosine. So one of the more famous cosine double angle formulas is cosine squared minus sine squared, right? 2 theta. So yes, you could do this one, cosine squared of theta minus sine squared of theta. But if you rewrite cosine squared using the Pythagorean identity, so this would be 1 minus sine squared of theta, right? If you just convert that, then what you'd have is 1 minus 2 sine squared of theta. So you can recognize that's where that comes from. Now again, this represents the cosine of 2 theta. So if theta is 30 degrees, right? If theta equals 30 degrees, then what is 2 theta? Well, then all you're going to do, 2 theta, is just 2 times 30 degrees, which you can see here is going to be cosine of 60 degrees. So there you go, ladies and gentlemen. That is the quiz I gave my students for our second part of analytic trigonometry. I can see you guys are going into the chat, and that's great. Let's see. I got a little bit of time. I guess I can check in with you guys, but hopefully, guys, hopefully that was helpful for you. And just wanted to kind of see, yeah, if you guys have any more questions, maybe I might be able to stay a little bit and answer your questions. Faked crisis. That's not very nice things. I didn't even know anything that geometry was. Oh, geez. Okay. Wow. You guys are, I guess, not being very nice to each other in the chat. So is this a live Q&A? Yeah, it's not my open Q&A, but yeah, I'm just kind of hanging out, seeing if you guys have any questions. I'm open now. I kind of already did what I needed to do. So I got some open Q&A. So if you do have some questions or anything you guys want me to talk about, then I'll be more than happy to maybe discuss and see what I can do for you. Well, good to hear, TNS Lover. Hope you did very well. And even if you didn't, it's fine. Like, I'm glad to see that you at least are over with your math exam. Hopefully that's at least a little bit of stress and some anxiety that you are over with. One less thing that you need to worry about. And, hopefully just a little breath of relief, because I know that math can be definitely some crazy stuff. So, Chris Blood, do you play Fortnite? No, unfortunately, I do not play Fortnite. I'm pretty busy. I really do not have any time to be doing. I mean, basically from teaching school to taking care of children to creating, more math resources that I use in my channel, as well as, in my classroom, to grading, to making videos, to doing live streams. I don't really spend much time doing a lot of extra stuff. So there you go. So I got a 67. That's good. Just keep working at it. Just keep working at it. A lot of people 67 in pre-calc, 68 in pre-calc. The one thing I think I mentioned, or one thing, there's always a lot of things I always want to talk about, that is math related, but it's not really like generally helping every student out there. But, guys, I know there's a lot of pressure, for a lot of students to always get A's and B's. And, sometimes you feel if you're not getting an A or a B, then, that there's your failure, or, you're not going to be successful in life, which I feel is like the complete opposite of, farthest from the truth that there can possibly be. Everybody is capable of doing pre-calculus. Everybody's capable of doing calculus. But not everybody needs to take pre-calculus. Everybody needs to take calculus. Or sometimes just the timing's not right. I mean, I remind people all the time, like, I struggled with pre-calculus in high school. I did not one, the timing wasn't right. Two, I wasn't there mentally, maturity wise, and I struggled with it really bad. And then I retook it in college. I was more focused. I was more motivated. And also I think I was just more mature to take the course. And I, did very well in it. But I mean, I literally went from a D in high school to an A in college. And it's not like I learned anything more. I mean, I did. Obviously I changed some things that I was doing, but I think there's a lot of pressure, for students to kind of have this perfection, or to always take these hard classes, and maybe when they're not ready for it. And I don't think there's anything wrong with, slowing things down and just making sure that you are, doing the path that's right for you and not really comparing yourself to anybody else that's maybe doing really, really well in in the class and, thinking, oh, they got an A in pre-calculus, like they're going to do better than me or, whatever else, which, is not the case by any means. So, I would say, obviously, guys, you want to do as best as you can do. And, sometimes, those D's and C's, just take them for what they are and just, keep on moving forward. I mean, I think the best thing is to learn from where you're making mistakes and just to keep on growing. And, that's really where I want to see my students going, is not to get frustrated with not getting the perfect scores, but to, try to asking those questions. Why did I get this wrong? What is it I'm not understanding? Why am I not understanding it? Sometimes it's previous classes that you didn't understand. Sometimes a teacher didn't teach you something. Sometimes you missed a class, so therefore you don't understand what we're going through in our class now. Like, there's all these different reasons why people are going to struggle, for a certain topic or a certain course. But I think as long as you're curious about that and keep on, not getting down just for one bad grade, that's going to help you out later on. All right. I'm not sure. You make no sense. I don't know, Cam Vanny, if you're talking to me or somebody else, but either. So Kira has an equation. What are you trying to do? Okay, well, I'll cover it. So I'm assuming you just want me to multiply 4 to the negative x plus 5 to the x times 4 to the negative x minus 5 to the x. Okay, well, now this one isn't as bad as we, I mean, it looks kind of crazy, right? But hopefully you guys recognize that this is just in the form of a minus b times a plus b, right? The first two terms are exactly the same. The last two terms are exactly the same. The only difference is one's positive and one's negative. So therefore, when we you could multiply these out using FOIL, but in reality, all we're going to do is do a squared minus b squared. Okay, so I'll come to that again. Guys, I'll see if there's any more questions. Whoa. Okay. Wow, some of you guys are just crazy for this. All right. So I will go ahead and get that old. Sweet. All right, guys. So I'm going to go and knock out this question, and then I am going to sign off from the live stream. So I appreciate you guys joining, and hopefully this quiz and topics we're going through. So, my main point is, guys, if you had like x minus 1, this is something we do all the time, at least in my class, x minus 1 times x plus 1. I tell students, yeah, you can multiply that out, but I don't really want you to waste the time multiplying out. That's going to be x squared minus 1, okay? So in this portion, this is going to be a 4 times negative x quantity squared minus a 5 to the x, 5 to the x quantity squared. All right, and then just remember the rules of exponents. What that tells us to do for the rules of exponents is to, multiply the powers. So therefore, this is 4 to the negative 2x minus 5 to the 2x. Okay, now there we basically are done, but there's a whole bunch of different ways that we could simplify this. We could write this as positive exponents. And this is where I don't know where your teacher is trying to go with this or your course is going with this. So now you can write them as positive exponents. You could combine them, right? So we could write it like this. Or maybe your teacher or your test wants you to have them written as a single expression. So therefore, now we need to get common denominators. So you can multiply by 4 to the 2x times 4 to the 2x. And therefore, we'd have 1 over 4 to the 2x minus, here I'm going to, oh, actually, you can't combine those. You can't multiply them because they don't have the same base. So, I mean, I guess you could write them overall. I don't think that's really a simplified version, but we'll write it anyways. So that'd be 1 minus 5 to the 2x times 4 to the 2x. So yeah, that doesn't really look too much simplified. So you could do that, but nobody, I don't think, is really going to want to do that. So either way, let's just erase that. I don't want anybody to look at this and be like, oh, that's what you're supposed to do. I mean, it could be if that's the directions and that's what you would do, but that doesn't really look like a simplified version. It'd have to really come through the directions. So I'd probably say usually writing as a, negative exponent or making them write as a positive exponent. All right, another question came in. Yeah, I can't read Gator's comments. X divided by 4th root of 64 minus x squared. All right, well, I don't know what I'm supposed to be doing. How to do integrals. No, I mean, I don't have enough time, guys, to go over more questions. I mean, as far as the integrals, I do have a whole playlist. I mean, probably of like 60 to 80 videos of me covering the integrals and at least talking about like the antiderivative first and then, understanding like the integral. So I'd recommend going from there. I haven't taught calculus in a couple years now, so I'm just not going to go through, like, I don't have my lesson as far as like how to best kind of introduce there to kind of meet you in there, because obviously understanding integrals, or at least explaining integrals, is a whole chapter. So to do that on the live stream is just not really going to do it to much justice. But either way, guys, I'm going to sign off. Yeah, it's been a great night. I will see you guys on my open Q&A next Sunday. For those of you that do have questions, look out for the community post, and you guys can post your questions there. And then I'll be more than happy to see what I can do to answer your questions. So again, guys, have a great night, and I will see you then. All right, cheers. I wonder if this works now. No, it doesn't. Okay, that's fine. This is kind of the annoying thing about this stream, is now I have to like manually turn this off. All right, now that's end stream, or it's supposed to. End, yes. Still some kinks.